All right, so today we're talking medians and altitudes of triangles. So our I can statements today are I can identify and use medians in triangles, and I can identify and use altitudes in triangles. So, did I skip? Yeah. So, first term, median. So the median is a segment from a vertex to the midpoint of the opposite side. So in each triangle, there's three medians. Examples being like right here from this point all the way up to A, that would be a median. Likewise, so would this yellow segment, and then this blue segment would also be a median. So like I said, there's three medians to each one, and the cool thing about these medians is when you find the centroid using all three medians, they're cut up into proportional lengths. So if we look at centroid, so centroid is the point where all three medians intersect, and it divides each median in a ratio of 2:1. So what that means, if we just look at our green one right here, so if we only look at this one for now, and then we have point G right here in the, not in the middle-ish of the triangle, but so that will divide AG into two segments, and this top segment is going to be twice as long as the bottom segment. So twice, let's just call this F. So 2GF. And then GF would be 1/2 of AG. Which this is really cool because it gives us a way to find a whole bunch of different measurements in a triangle with only knowing the length of one of these medians. The other way that we can figure this out is if they gave us the length of AF. So let's just say AF equals, I don't know, 24. Then we know AG is going to be 2/3 of AF, and then GF is going to be 1/3 of AF. So the top is 2/3 of it, the bottom is 1/3 of it, and we could find all these individual lengths, which AG would end up being 16, and then GF would end up being 8. But so centroids and medians are really cool in that way, where we can find a whole bunch of different measurements. So once again, median, whenever I think median, I think middle, because when we find mean, median, and mode, the median is that middle number. And then the centroid is where all the medians intersect, and medians go from midpoint to the opposite vertice. Now, altitude. So the altitude is a segment from a vertex that intersects the opposite side at a 90-degree angle. So whenever I think of this, I think of the height. Because whenever we're finding area, they always have the altitude drawn in, or the height. It's from that top point, and it drops down, and it intersects that bottom line at 90 degrees. And these don't necessarily have to lie within the triangle. So if I had a triangle like this, an obtuse triangle that's really, really shaky, then my altitude from this top point here, it would drop straight down, and it would intersect the line at a 90-degree angle there. So it wouldn't necessarily have to be inside the triangle, which is another really interesting part of this. So the orthocenter is the point where all the altitudes intersect. And the orthocenter is not as cool as the centroid. It doesn't like cut things up into neat little pieces for us. But we will be asked to find a number of orthocenters, which I'm going to show you a trick for in another video. For now, we're going to have to do it longhand, though. So, let's hop into centroid theorem, I guess. So, the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint on each side, or on the opposite side. So if P is the centroid in this example, then AP is 2/3 of AK, and BP is 2/3 of BL, and CP is 2/3 of CJ. So that's kind of what we talked about a couple slides ago, where each individual piece of these is cut into thirds. So this would be 2/3, this would be 1/3, likewise 2/3, 1/3, 2/3, 1/3. All right. I keep skipping slides on accident. Bad habit to get into. So in triangle XYZ, P is the centroid. So this middle point, P, is the centroid. And YV is 12. So this whole chunk here is 12. Find YP and PV. So right away, YP is the whole chunk, and that's 12. So I know 12 equals YP plus PV. And I can go about this two different ways. So, well, actually 3 different ways if you want to get technical. So I could say 12 is equal to YP plus PV, and YP is 2/3 of YV, which was 12, and PV is 1/3. Be helpful to actually make it a third. 1/3 of 12. So that's one way I could do it. The second way I could do this is I could say, okay, YP is twice PV. So I could say YP is 2 times PV plus PV, which would mean that 12 equals 3 PV, or PV equals 4. And then I could plug that 4 back in and say, okay, PV equals 12, which means YP equals 8. So I could do it that way too. Or my third way that I could do this is I could say YV equals 12, so I'm going to write 12 equals, it would be YP plus 1/2 YP, because PV is 1/2 of YP. So I could say, where'd my slide go? So I could say 12 equals 1.5 YP, and then I could divide by 1.5, and I could find out that YP equals 8, and then I could say, okay, well, PV is 1/2 of YP, so PV is going to be 4. So there's a number of ways to solve these. Personally, I believe the easiest way is this red way. Given if they give us the whole length of the median, I believe it's probably the red way. Then the green way is probably the second easiest, and then the blue way to me is the third easiest. Now, it is all personal preference though, and some situations might make individual equations easier than others, but it really is dealer's choice. I never did finish the green equation, but I would say 2/3 of 12 is 8, plus 1/3 is 4, equals 12, and then our corresponding side, so YP would be 8, PV would be 4, since we kept everything in the same place. So there's a number of different ways to solve it. If you like having multiple options, this is good for you. If you don't like having multiple options, I would choose either the red or the green option to stick with in this case. So continuing on, this is a problem that you guys will solve individually on the Zoom, but I will just give you the answer super quick. And it says in triangle LNP, R is the centroid, and LO is 30. And they want us to find LR and RO. So the correct answer will be B. Continuing on, in triangle ABC, CG is 4. Find GE. So in this case, I'm going to use one of these other equations. So I'm going to say, I'm probably going to use the blue one in this case, because I don't know what CE equals. I know CG equals 4, and then I know GE is going to be half of 4. So I would then know GE, label that GE, and then this one's going to be CG. So GE, I know would end up being 2. And then CE would be 6 if we really wanted to find that, but they didn't ask us to, so we don't have to. All right, so continuing on, another problem that you would solve individually. The correct answer is D. So, sculpture. An artist is designing a sculpture that balances a triangle on top of a pole. In the artist's design on the coordinate plane, the vertices are located at 1, 4, 3, 0, and 3, 8. What are the coordinates for the point where the artist should place the pole under the triangle so that it will be balanced? Okay, so we have to graph this. It's already graphed for us. Then we have to find the midpoint of each of these individual segments, which is lovely, because we all love the midpoint formula. And then from there, we will, of course, draw in our medians, and we will find our centroid that way. So let's see here. Oh, they already gave us one of our midpoints. That was very nice of them. So I can tell this is going to be another midpoint, and so is this. I can tell that because if I look at the slope, it's going down 2 over 1, down 2 over 1. And so if I go down 2 over 1 once, then I'm halfway there. And likewise, this is down from B to A, it's down 2 left 1, down 2 left 1. So if I only go down 2 left 1 once, I'm halfway. Now, I'm going to draw in my medians and get a rough estimate of where my centroid is going to be. So it's going to be somewhere in here. Now, that's not exact though. So for us to find our centroid, we have to find, essentially, we can choose any one of these lines. I'm going to choose AD. So we have to find the distance between A and D, or any of these lines, any of these medians. So I can see AD is 1, 2. So I know the distance of AD is 2. And then we have to find 2/3 the distance from A, or 1/3 the distance from D, because this is 2/3, this is 1/3. Now, this is where it gets to be a mess when we have to do it longhand, because we're going to have just a nasty point here. But that's okay. So, actually, my final answer, I know I'm going to have a height of 4, which makes it a little easier. So I'm going to have a height of 4. I just need to find that other coordinate. So I'm going to choose to go 1/3 of 2. So 1/3 of 2 which would be 2/3. Okay, that was cool. Cool. So 1/3 of 2 is going to be 2/3. So that's 1/3 of my distance of AD, but I need to move 1/3 of that distance back to the left. So I'm starting at 3, and I need to go 2/3, or I need to go 1/3 back, which is going to be the actual measurement of 2/3. So I need to do 3 minus 2/3. So I'm going to write that as 3 over 1, which is the same as 9 over 3. So I'm going to subtract straight across, and I'm left with 7 over 3. So 7/3. So my centroid should be 7/3 over 4. Oh, this is a different problem. Yeah, so my centroid would end up being 7/3 over 4. The cool part about this is there will be a second video posted. There is a program online that we can use to do this, and it makes it a lot quicker. Now, this problem will be up to you to solve. So if we continue on, we can say that our centroid would be 2/3. So 2/3 from there. 1/3 that way. Which is going to be. Let's draw these in. So 1/3 of it, which is going to be 2/3. So it's going to be, hey, cool. Oh, I already had the answer in there. So that's fun. All right, so orthocenter is our next bit that we are going over. So orthocenter, the lines containing the altitudes of a triangle are concurrent, intersecting at a point called the orthocenter. So if we take all our heights or altitudes and we connect them, then our middle point here is going to be the orthocenter. Find the vertices, or the vertices of HIJ are those points. Find the coordinates of the orthocenter. So this is the next really fun bit. Did I give a second slide in here? I did. Good. So we look at this triangle. We have to find all of our altitudes, which means we have to find the slope of each line, and then we have to find the perpendicular slope, which, if we remember, the perpendicular slope, so if I had a slope of 2, then my perpendicular slope, if I can draw that symbol correctly, my perpendicular slope is going to be -1 over 2. So it's the opposite inverse. So we have to flip it and change the sign. So let's start with JH. So my slope is a rise of 1, JH. My slope is a rise of 1 and a run of 6, which means my perpendicular slope to that would be -6 over 1. So I'm going down 6. I'm going to start at point J. I'm going to go down 6 and over 1. All right. Does that make sense? No, because yeah, no, that's correct. But that doesn't. Yeah, because that would be the intersection. I think. I'm so confused. Oh, okay. So that is my issue, right? Gotcha. Right? Down 6, so up 6. Yes, okay. Confusion. So I would go down 6 and over 1 from this point, or up 6, left 1. So that's one of my heights. Because it's perpendicular to this line, to JH, which means if it's perpendicular to JH, it's going to intersect at point I, which I didn't want to erase that. So that's going to be our 90-degree angle there. Now our next one is IH, and our slope of IH is going to be up. Our rise is 4. Did they graph this wrong? No. Our rise is 5, and our run is 4. So our rise is 5, and our run is 4, which means our perpendicular one would be negative 4 over 5. And negative 4 over 5, so we're going to go down 4 from point J and right 5. Down 4, right 5. 1, 2, 3, 4, 5. So we're going from there to there. So if I connect that like that, we have a 90-degree angle there. Now our final slope that we need to do is JI. So JI, our slope is negative 2, or negative 4 over 2, which we would reduce to negative 2 over 1. And then perpendicular to that would be 1/2, because we flip it and we change the sign. So from H, we're going to go up 1, right 2, or down 1, left 2. So down 1, left 2, down 1, left 2, down 1, left 2. And we're going to connect those. And we have a nice 90-degree angle there. So our orthocenter is somewhere over in here, which is just going to be a messy, messy, messy area. Now, there's really no way for us to find it without the computer program, the exact point. What we could do, which would take forever, would be to set up a system of equations, but it's just not going to work for this one. Now, this lovely problem has more reasonable slopes, so we could actually figure this one out. So our slope on this one, we'd go up 3, up 6, no, up 6, right. 1, 2, 3, up 6, right 3. So that'd be a slope of 2. So it would be negative 1/2. So all right. So we'll just give you the example there. So using GeoGebra, we can find that it's 0, 1, B. Cool. GeoGebra is going to be our friend for this section, which means you really need to watch that